Hi guys, I'm going to be explaining how to do safe and not safe algorithm checking. Okay, so in this question we have 5 processors with 3 resource types. Okay, so we have 5 resource types, meaning 0, 1, 2, 3, and 4, with 3 resource type being A, B, and C. Okay, so we have a question and we have already given all these values. So this is our question, right? So in our question we already given you max, allocation, and available, so which is right here. Okay, now we're going to move on to the first thing. First thing is total instances. Total instances formula is total allocation plus available Okay, so for your allocation or your max, when you are adding up, you are not going to go horizontally, you are going to go vertically down. Okay, so let's start. For total instances for A, okay, so what you're going to do is you're going to just add row by row. I'm highlighting so you can see what I'm talking about. So you start 4 plus 1, 5, 5 plus 1, 6, 6 plus 0, 6, 6 plus 0, again 6. 6 plus A is available, right? 6 plus 1 is 7. So let's go check if the total instances is 7. 7, that is correct. Okay, now next we have B. So we're going to do the same thing for B as well. Okay, so 2 plus 1 is 3. 3 plus 0, 3. 3 plus 3, 6. 6 plus 0 is 6. Now the available for B is 3. So 6 plus 3 is 9. 9 right here. Okay, now we're going to move on to C. So C's allocation, 0 plus 0, 0, 0 plus 5, 5, 5 plus 0, 5, 5 plus 2, 7. So now we have a new allocation for C as 7. 7 plus 3, which is available for C, is 10. Is 10, right? Now we're going to be moving on to the second question, sorry, which is neat. So to find the neat, we also have a formula, which is max minus allocation. So when you're doing this, it does not mean that you're going to find max and allocation horizontally like this, because this means that you're finding it for all 3 resource types, A, B, and C, which is wrong. We just want to find it for 1 resource type, okay, because then we will jot it down after that. Okay, so when I say max minus allocation, for A and P0, okay, you're going to do 7 minus 4. 7 minus 4, you get 3. You're going to get 3. Put that in the table. Okay, 1 minus 1, you get 0. 1 minus 1, you get 0. And then you get 2 minus 1, which is 1. 4 minus 0 is 4. And 1 minus 0 is 1. So 1, 4, 1. 1, 4, 1. Okay, now we're going to move on to B now. So for B, same thing. 4 minus 2 is 2. 3 minus 1 is 2. 3 minus 0 is 3. 6 minus 3 is 3. And 6 minus 0 is 6. So 2, 2, 3, 3, 6. Okay? So 2, 2, 3, 3, 6. Okay? Now we're going to move on to C. C is 3 minus 0, 3. 2 minus 0, 2. 6 minus 5 is 1. 5 minus 0 is 5. And 3 minus 2 is 1. So it's 3, 2, 1, 5, 1. Okay? So 3, 2, 1, 5, 1. I've already done a table, and we're going to check below if the answers are the same or not. Okay, so for A, let's check A, right? It's 3, 0, 1, 4, 1. Let's check here. 3, 0, 1, 4, 1. That's right. Okay, for B, it's 2, 2, 3, 3, 6. Check. 2, 2, 3, 3, 6, correct? And for C, it's 3, 2, 1, 5, 1. 3, 2, 1, 5, 1. 3, 2, 1, 5, 1. Now moving on to part 3 of the question. Determine whether the system is in safe condition. If true, provide the allocation sequence. Okay, so this is at the end. So now we need to go process by process. So it's called safety algorithm. Okay, so in your safety algorithm, this is what you're going to do. Is need less than available? Okay, so is available, technically how you're reading it, right? Is available greater than need? Now, where are you going to get your need? Where are you going to get your available? So your need, you're going to start from P0 because it's your first process. Okay, so P0, you did from your need table here. So 3, 2, 3. And your available is from your table that you have given. So your 1, 3, 3. Now, start the question. Available greater than need. So, is 1 greater than 3? No, false. When 1 itself is false, the whole process will be false. The whole process is wrong. So you're going to straight put false. It's going to go back down into the processes, and when it's time, when it can be processed, it will be recorrected. So we're going to reconfigure it later on. So we're going to move on to the next process first, which is P1. Moving on to process P1. Okay, so again, you're going to go to your need table, is 0, 2, 2. Okay, and you're going to be using the same available because the first one, it was already wrong. So you're going to move it back to the next one. Okay, so is 1 greater than 0? Yes, true. Is 3 greater than 2? Yes. Is 3 greater than 2? Yes. So this whole process is true. This whole process is true. Okay. Now, you're going to move on to process 2. To move to process 2, you need a new available. So, to get a new available, you are going to do the current available, which is 133, plus, you're going to go to your original table for your process 1. So you need to get a new available, which is your allocation, right? Your allocation here is 1, your B allocation is 1, and your C allocation is 0. So your new allocation is going to be 1, 1, and 0. Okay? So that's what you're doing here. Your new available, your new available here is 1, 1, 0. Okay, so 1 plus 1, 1 plus 1, you get 2. 3 plus 1, you get 4. 3 plus 0, you get 3. So this is going to be your new available for process 2. So we move on to process 2 now, yeah? So where did you get this 1, 3, 1 from? Is your need table. So for process 2, right? 1, 3, 1. With your new available that you have solved here. Okay? So start. Available to need. Is 2 greater than 1? Yes. Is 4 greater than 3? Yes. Is 3 greater than 1? Yes. So this process 2 is also true. So when it's true, you're going to have to find a new available. Okay? So a new available is going to be your current available plus your processor 2's allocation. So you're going to go to your process 2 in your table, process 2. So you have your allocation here is 1, 0, 5. 1, 0, 5, right? So we're going to go down. Okay, so you have your available, which is 2, 3 plus 1, 0, 5. Okay, so start. 2 plus 1. 2 plus 1 is 3. Then 4 plus 0 is 4. And 3 plus 5 is 8. So that is going to be your new available process 3. Okay, now moving on to process 3. So for process 3, you get 4, 3, 5 from your need table. So 4, 3, 5. And from your given found available, your calculated available from P2. Okay, so it's going to be 4, 3, 5 and 3, 4, 8. Now, is 3 greater than 4? No. So automatically this process is going to be false. It's going to be false. and you're going to just move on to the next process while pushing this down, all the way down, to reconfigure later. Okay, so now we're going to move on to process 4. So process 4 is supposed to be 1 for 1. Oh, sorry. Hold on. So coming back to this. Okay, so we have P4, which is 1 for 1 from our new table, and 3 for 8 that we have found from P2. Because P3 was false, we're still going to be using the same available that we have calculated. Okay, so 3 for 8. Now, is 3 greater than 1? Yes. Is greater than or equal, by the way. Okay, so it's 4. Is 4 greater than or equal to 4? Yes. Is 8 greater than or equal to 1? Yes. So this P4 process is going to be true. Now since it's true, you're going to have to find its new available. So you have to find new available, which is 3 for 8 plus process 4's allocation. So process 4 has allocation of 0, 0, 2. 2. Okay? So 0, 0, 2. This is your available here. So 3 plus 0 is 3. 4 plus 2 is 6. And 8 plus 2 is 10. Okay, so that is correct. So you've already done from P0 to P4. And you have only found 3 that are true and 2 that are false. So in order to have it in safe state, you're going to have to make it all true. Right? So now you're going to go back to whatever you've pushed in. So push in that you've done was P0 first. Okay, so P0. P0's first thing was 3 to 3. From where? Here. Same thing. Same thing, same neat table, yeah? 3 to 3. With your new available. Okay? That you have calculated at process 4. Okay, so is this 3 greater than or equal to this 3? Yes. Is 6 greater than or equal to 2? Yes. Is 10 greater than or equal to 3? Yes. So now process 0 is also true. So now that's also functioning. So since that is true, you're going to add in a new variable. Right? So you're going to add in a new variable, which is 360 plus 420. 420 is from process 0. So 420 from process 0's allocations. Okay, so by doing that is, so 4 plus 3 is 7. 4 plus 3 is 7. Then you have 6 plus 2 is 8. 6 plus 2 is 8. And then you have 10 plus 10 plus 0, 10 plus 0 is 10. Now we're going to move on to the last push in, which was P3. P3 is 435 from its neat table, and then 789 from this new available that you have found. Okay, so is 7 greater than or equal to 4? Yes. Is 8 greater than or equal to 3? Yes. Is 10 greater than or equal to 5? Yes. So that is also true now. That means all your processes are now true and they're all going to be in safe state. Now, for your final available, so you can, all your values are already stacked, yeah? You just need to add in your last available with your last processor's allocation. So your 789 plus 030 from P3. So P3 0 3 0. Okay. So 780 plus 030. So 0 plus 7 is 7. 3 plus 8 is 11. And 0 plus 10 is 10. So when you're going to put this in safe sequence, you're going to start from which was first to the end. Even if process 0 is the first one, it was not true and it was not correct in the first alignment. So after you try and change its available and add in values, if it's true, you add it to the end. Okay, so your first one was P1. So as you can see, P0 is false, so you have P1. Then you have P2. P3 was false, so you move that down below 0. So then you have P4 was true. So it is P1, then P2, P4, P4. After P4, we redid P0, which became true, and then P3 was true again. So that means your safe sequence is P1, P2, P4, P0, and then P3. Okay? So in conclusion, this means that your system is in a safe state and deadlock can be avoided. So this is the first part. So now moving on to the next question, which says, suppose now process 3 requests additional instances 0, 1, 1. Can it be granted? Okay, so there are two steps to this, which is your need part and then your available part. Okay, so first it says step 1. Okay, so check request that process 3 is less than or equal to need. So is your need greater than or equal to P3? Okay, so the request is 0, 1, 1. And the P3 you get from your need table above that we have already solved, right? So P3, you have 4, 3, 5. So it's from your need table. Okay. Go back. Now, is 4 greater than or equal to 0? Yes. Is 3 greater than or equal to 1? Yes. Is 5 greater than or equal to 1? Yes. So this is true. The need part is true. Now we're going to move on to step 2, which is available. Now, request again is 0, 1, 1. Now, same thing, 1, 3, 3. It's available, right? Where do we get this available from? I'll show you. 4, 3 is here. This is your original available for all the questions, right? For all of the availables. Now, is 1 greater than or equal to 0? Yes, that's true. Is 3 greater than or equal to 1? Yes. Is 3 greater than or equal to 1 here? Yes, so this is true. So that means your request is less than or equal to. So it has been granted. Okay, for the resource request algorithm. Now you're going to move on to the second part, which is Banker's algorithm. For Banker's algorithm, it's a resource allocation and deadlock avoidance that tests for safety, simulating by predetermining the maximum numbers. Okay, so that's what you're going to do. Now, see, the question only states for P3, so do not change or look at any other processes, right? So for Banker's algorithm, you're going to look at the allocation, which is your maximum. It includes your maximum and your allocation, okay? So for your allocation, okay, this is your allocation table that we have found just now, right? Original table. So you see your process 0 is 4, 2, 0, right? So same thing here for process 3, you're going to have 0, 3, 0. Okay, so 0, 3, 0 here. So you have 0, 3, 0 plus 0, 1, 1 from its granted, the instances that they have given you. Okay, so that's your new allocation. Okay, so for, yeah, so you're just going to add 0 plus 1, 0 plus 0 is 0, 3 plus 1 is 4, and 0 plus 1 is 1. So your new allocation for process 3 is going to be 0, 4, 1. So you're going to change this to 0, 4, 1. So 0, 4, and this is 1. That is your new allocation. Now, after you're done doing that, you're going to need to find your new need. Now, how do you find your new need? Max minus allocation. But you already have a new allocation, so you have to follow the new allocation. So your max was 465. Where do we get this value from? From the max. Not need table here, it's from max. From max of P3. So 4, 6, 5. Okay, that's your need, which is maximum minus your allocation. So that's your max 465 minus your new allocation. Your new allocation here is 0, 4, 1. Okay, so 465 minus 0, 4, 1. So 4 minus 0, you get 4. 6 minus 4, you get 2. And 5 minus 1, you get 4. So this is your new need. So you also have to change it in your need table. So in your new need, it's going to be 4 to 4. Now, you have to change your available also. Now, your available originally was 133. It's available for all of it. For all processes, it was 133. Now, to find your available, you're going to minus it from what they want in the question. Minus 0, 1, 1. 0, 1, 1. Alright? So it's going to be 1 minus 0 is 1, 3 minus 1 is 2, and 3 minus 1 again is 2. So your new available is 1, 2, 2. Okay, so then you have your neat and you have your new available. So that's how you're going to solve all these questions now. Now, the second part, since they said they want it only for process 3, you're going to do a safety algorithm check. Okay, so same thing. Is your available greater than your need for process 0, 1, 2, 3, and 4? And in conclusion, you'll know if your system is safe or not. Okay, so start P0. Where do we find this need? From the need table that we have originally found. So 3, 2, 3. We're just going to be using this need table again. Okay, so let's go back. Okay, so we have your need and your available that you have already calculated here above, your new available. So is 1 greater than or equal to 3? No. So automatically this process is going to be false and it's going to be pushed down. Okay, so it's just going to be false. Now move to P1, process 1. 0 to 2, again from the need table. So 0, oops, again 0 to 2. Okay, so we go back to 0 to 2. And 1 to 2, which is the original available. Since P0 was declined, we're going to use the same available. Okay, so is 1 greater than or equal to 0? Yes. Is 2 greater than or equal to 2? Yes. Is 2 greater than or equal to 2? Yes. So this process is true. Now, when it is true, we're going to get a new available from where? We're going to do 1, 2, 2 plus 1, 1, 0 for P1. So you're going to go all the way to the allocation table, which is here. Original allocation table is 1, 1, 0. Okay? Or you can just use this table, which is easy. 1, 1, 0. Okay? So 1, 1, 0. At 1 plus 1 is 2. 2 plus 1 is 3. 2 plus 0 is 2. So this is going to be your new available for process 2. So process 2 is 1, 3, 1 from the need table. And we're just going to do it with this available that we have found in the previous question. So is 2 greater than or equal to 1? Yes. Is 3 greater than or equal to 3? Yes. Is 2 greater than or equal to 1 here? Yes. So this process is true. Now if it's true, we need to find its new available for the process 3. Okay, so 2, 3, 2 here plus 1, 0, 5 here. 1 process 5. So process 2 is 1, 0, 5. So we're just going to go to the original table. Process 2, 1, 0, 5. Correct? 1, 0, 5. See? Process 2, 1, 0, 5. So, here, we're at process 2 now. So 2 plus 1, you get 3. Okay? 3 plus 0, you get 3. And 2 plus 5, here you get 7. Okay? Now we're going to move on to process 3 since it's there. So, process 3, where you get the 3, 3, 4 form is from the need table and your available that you have found in the previous question. Okay? So, is 3 greater than or equal to this 3? Yes. Is this 3 greater than or equal to this 3? Yes. Is this 7 greater than or equal to 4? Yes. So since it is true, you're going to have to find a new available for process 4. Okay, so 3, 3, 7, here is the available. Plus 0, 4, 1 is from process, the new one, the new allocation. So 0, 4, 1. 0, 4, 1. Here. Okay, so 3 plus 0 is 3. 3 plus 4 is 7. 7 plus 1 is 8. So this is going to be your new available for process 4. Okay. So now we're going to do process 4. 1, 4, 1 from the need table and 3, 7, 8 from the available that we have found above. So same thing. 7 is 3 greater than 1? Yes. Is 7 greater than 4? Yes. Is 8 greater than or equal to 1? Yes. So this is also true. Since this is true, you need to get a new available because initially process 0 was false because of the first number itself. So we're going to add in a new available. So 3, 7, 8 plus 0, 2, 2. So you're getting this from the allocation table. 0, 2, 2. Okay. So 0, 2, 2. Here. 0 plus 3, 3. 2 plus 7, you get 9. And then 2 plus 8, you get 10. 10 here. Okay? So that's going to be your new available for P0. Now P0, 3, 2, 3 from the neat table. And this is your new available that you have found. Okay. Try. Is 3 greater than or equal to 3? Yes. Is 9 greater than or equal to 2? Yes. Is 10 greater than or equal to 3? Yes. So P0 here is also true now. Now you have to find the final and last available. Okay? So your 390 plus your 420. Your 420 from your allocation table for P0. Okay? 420. Okay? 420. Your new available. Okay? So 3 plus 4 is 7. Okay? 2 plus 9 is 11. And 0 plus 10 is 10. Alright? So that means that's how when you're doing your safe state sequence, you look back. Which one was true first? So 0 was pushed down, so it goes all the way to the bottom. First was P1, then P2, then P3, P4, followed by P0 and the bottom. So your safe sequence would be P1, P2, P3, P4, and then finally P0. Okay? So your conclusion would be the request 011 of total instances from P3 can be granted as the system is in safe state and deadlock can be avoided. Thank you very much. I hope you guys understand from this.